Hello everyone, I'm Atharva Saranke, and with my partner Vishal Pednikar, we are here to explore the fascinating and sometimes dangerous world of web security. Today, we'll be demonstrating three major web attacks: SQL injection, cross-site scripting, and cross-site request forgery using a dummy social networking site we've built. We'll show you how these attacks work, how they can be exploited, and most importantly, how to defend against them. After all, in the world of web security, it's better to be a sheriff than the outlaw. Before we dive into the attacks, let's talk about why web security matters. In today's digital age, web applications store sensitive data, everything from personal information to financial records. This makes them prime targets for attackers. Despite advancements in technology, many systems still have security flaws that can be exploited. Common threats like SQL injection, XSS, and CSRF are still prevalent, leading to data theft, impersonation, and system manipulation. High-profile breaches, such as the one we have seen with companies like Equifax and Facebook, highlight the importance of robust security measures. The good news is that there is a growing focus on developer awareness, security training, and tools like AI and bug bounty programs. To mitigate this risk, our vision for a secure web includes strong input validation, encryption, and zero trust security models. But to get there, we first need to understand the threats we are up against. Now let's talk about SQL injection, the Darth Vader of web attacks. This is where attackers manipulate database by injecting malicious SQL queries. Imagine someone slipping a fake key into a database log and walking away with all your secrets. Scary, right? SQL injection was first discovered in the late 1990s when attackers realized they could exploit poorly secured database queries by injecting malicious code into input fields. It gained widespread attention after high-profile breaches like the 2009 Heartland Payment Systems Hack, where attackers stole millions of credit card details. The real danger here is that the attackers can extract sensitive data, modify or delete records, and even gain administrative access. Basically, they can take over your entire system. Next up, we have the cross-site scripting or XSS. This is where attackers inject malicious scripts into a website, turning it into a Trojan horse. There are three types of XSS: reflected, stored, and DOM-based. It was first discovered in the early 2000s when security researchers noticed that attackers could inject scripts into web pages through user inputs. One of the earliest and most famous cases was the MySpace Sammy worm in 2005, which we'll talk about next. The real kicker: attackers can use XSS to steal cookies, deface websites, or even launch phishing attacks. It's like someone sneaking a harmful virus into your bloodstream, silent but deadly. And if you think this is just theoretical, think again. The Sammy worm is a perfect example of how devastating XSS can be. Let's rewind to 2005, a time when MySpace was the king of social networking. This was the year the infamous Sammy worm emerged, a persistent XSS worm that spread like wildfire by automatically adding Sammy as a friend whenever the profile was viewed. The worm was discovered when MySpace users started noticing something strange. Their profiles were adding a user named Sammy as a friend without their consent. MySpace's security team quickly identified the worm, but not before it had infected over 1 million users in just 20 hours, forcing the site to shut down temporarily. Don't worry though, we'll show you how to defend against such attacks so that no one has to resort to worming their way into your social circle. Finally, we have the cross-site request forgery or CSRF. This attack tricks authenticated users into performing unwanted actions by exploiting their trust in an existing session. CSRF was discovered in the early 2000s when security researchers realized that the attackers could craft malicious links or forms to execute actions on behalf of the user. One of the earliest documented cases involved online banking, where attackers tricked users into transferring money without their knowledge. The scary part: CSRF can lead to unauthorized transactions, data modifications, and even privilege escalations. It's like being in a dream within a dream, except the consequences are very real. So here's a dummy social networking site we have built to showcase some common web vulnerabilities. This app was developed using Flask for the backend, SQLite for the database, and Bootstrap HTML CSS for the frontend. It's designed to mimic a real social media platform, complete with features like user registration, posting updates, and connecting with friends. Let's walk through the app's features to understand how it works. First, users can register for an account or log in using their credentials. Once logged in, they can post updates which appear in the feed for others to see as well. They can also search for their friends and add them. And the followers and following list gets updated dynamically. The users also have the ability to update their bios. Now let's move on to the attack demonstration. In a real-life scenario, hackers often combine multiple vulnerabilities to perform a sophisticated attack. Instead of showing individual vulnerabilities, let's see how an attacker uses multiple tools to break into the system and cause widespread damage. For the purpose of demonstration, we have an attacker server set up at the port 3000 and our web app is running on server 5000. The attack begins with SQL injection, where the hacker exploits a vulnerability in the login form. Instead of entering valid credentials, they input a malicious string like such. They can use any password to log in. This manipulates the SQL query to always return to true, allowing the hacker to log in as the first user in a database, no password needed. With unauthorized access to the account, the hacker now has a foothold in the system. Once inside, the hacker uses cross-site scripting to inject a malicious JavaScript post. They create a post containing a script that isn't properly escaped due to the save filter in the template. This script is designed to trigger a CSRF attack when another user clicks on the malicious link in the post. Now let's log in as another user. Now comes the CSRF attack. When an unsuspecting user clicks the link, the hacker script forces the victim's browser to send a request to the app's create post endpoint. Since the victim is already logged in, this app processes it as legitimate, and the victim unknowingly makes a post containing an XSS worm, as we can see here. This is where the worm gets embedded. The infected post is now on the victim's profile, and whenever another user logs in and views a profile, the worm executes in their browser as well. Let's create a new user to check if that works. The new user is just viewing the infected profile. Now let's get back to our profile, and as we can see, there's a new post and the worm has spread. So what the worm does is it replicates itself by copying itself to the new victim's profile and even stealing their sensitive information like cookies and session tokens, as we can see here. The worm continues to spread, creating a chain reaction that compromises multiple accounts across the platform, as we can see in our database.
Now, let's talk about how we tackle these vulnerabilities and strengthen the security of our website. So let's start with SQL injection. From the previous segment, we saw that typing something like this within the username section and then typing literally any password in here would give access to the first account that's available in the database. As you can see, this no longer works. So this is our login method that we are using for our login action. Here we can see a change. So instead of using a raw SQL statement which was insecure and prone to SQL injections, we are using models provided by SQL Alchemy. SQL Alchemy by default will not allow for SQL injections and will use prepared statements somewhere internally. Another change over here is to hash the passwords. Instead of using passwords in plain text, now if we go back to our user model, so I have added a logic to set the password and generate a secure password hash. Now let's move on to XSS or cross-site scripting attack. For that, I have already logged into my account. I'm going to post this script tag which contains a link to worm.js. I'm going to post this. You can see the script tag right here in plain text as compared to attack when you couldn't see the text at all. To check out if the worm.js thing is working or not, I'm going to log out, log into another account. I'm gonna search for myself, that's me. Now I have viewed the tag. If XSS was working, the script would execute and I would have some post on the test website. I'm going to profile and we can see there are no posts for test. That's how we know that XSS did not work in this case and it's fixed. Let's check our code. So the very first thing I did was to update the models themselves to not allow plain text to be saved to the database. When making a post, I'm using the bleach library to clean the inputs. So this is going to strip everything that should be harmful and it's going to replace them with safe text. I have also added some tags that are safe to use. I think those can be allowed in a post. So effectively we are sanitizing all the inputs before we are storing them to the database. Moving on to the CSRF attack. Now I'm going to make a different post. Alright. So I made this post and because I have allowed some tags while cleaning, we are able to see that this post is rendered properly. I'm going to click on the hyperlink. If CSRF had to work, I would see something on my profile. I should be able to see a new post. I'm seeing only 2 posts over here, not 3. So that's how I know that CSRF ain't working. Even if I click something, nothing's gonna happen. So first thing is we are setting the CSRF token before the request takes place. We are sending the CSRF token in the response after the request. For every form that we have in our website, we are going to add a input which will be hidden but will contain the CSRF token that we just created before the request. It will be embedded in our HTML from our session. So we would set the CSRF token in the session. We get the value over here. This token will be passed with the request. This is the login method. And over here we are checking if the CSRF token is valid or not. We would get the CSRF token from our form and compare it with what we have in the session. This is the post method. Even this has the CSRF protection. When this website over here was trying to make a post, it was not sending the CSRF token. There's no way for this website to pick up our CSRF token. That request will automatically get rejected. So today we explored 3 major web security threats: SQL injection, XSS, and CSRF, each showing how poor security practices can lead to severe consequences. SQL injection exploits unsanitized user input, emphasizing the need for prepared statements and ORM security to protect databases. XSS attacks occur when unsanitized content executes malicious scripts, making input validation, output escaping, and content security policies or CSPs essential. CSRF attacks take advantage of state-changing actions without verification, highlighting the importance of CSRF tokens and same-site cookies to prevent unauthorized actions. The biggest takeaway here: security must be proactive, not reactive. That is, small oversights like weak session management or missing input sanitization can open the door to major vulnerabilities. To conclude, web security is an ongoing challenge. New attack methods emerge constantly, so staying ahead requires continuous testing, monitoring, and updates. Developers must prioritize secure coding by integrating automated security testing, vulnerability assessments, and dependency updates into the development process. To prevent future threats, we will adopt a security-first mindset, ensuring that best practices are followed consistently and security is built into every stage of development. For a final thought, preventing attacks through secure coding, validation, and authentication is far more effective than fixing breaches later. By staying proactive, we can build web applications that are not just functional, but truly secure. Let's make security a habit, not just a fix.